What if I told you that 30% of Earth's land surface is so extreme that humans once thought nothing could survive there? Yet life not only survives, it thrives through remarkable adaptations. Welcome to Earth's Group B climates, the driest regions on our planet where science, survival, and stunning landscapes collide. Today on our channel Earth Diary, we're decoding the fascinating secrets of deserts and steppes. These breathtaking landscapes aren't just visually stunning, they're scientific marvels covering a massive 42 million square kilometers of our planet. In the Köppen climate classification system, they form Group B, the only climate group defined by moisture deficiency, rather than temperature. But here's what makes them truly fascinating: their formation follows predictable patterns, driven by global atmospheric circulation, continental positioning, and mountain barriers. In the next few minutes, we will explore 4 distinct dry climate subtypes of Köppen's dry climates. So what makes a climate dry? Before we dive into the subtypes, let's clear up what actually makes a climate dry in Köppen's system. It's not just about low rainfall, but the relationship between water coming in through precipitation and water going out through evaporation. A Group B climate exists, where yearly precipitation is less than potential water loss through evaporation. This balance depends on 3 key factors, which are annual precipitation totals, temperature which drives evaporation rates, and seasonal distribution of precipitation. These factors explain why 25 centimeters of rain can support forests in cool Scandinavia, but only sparse vegetation in hot Nevada. The same amount of water, but in different locations, simply disappears faster in hot air by evaporation. Within Group B, Köppen identified 2 main types defined by the precipitation they receive. They are true deserts or BW, where water deficiency is extreme, and steppes or BS, semi-arid transition zones with moderate water deficiency. Each is further divided by temperature into hot subtropical or H and cold mid-latitude or K varieties, creating 4 distinct dry world environments that are BWH, BWK, BSH, and BSK. Let's explore each one. Do you know that the H is for heiß, that means hot in German, where the K is for kalt, that means cold in German? First up are BWH, the subtropical hot deserts. These are the superstars of the dry world, including the mighty Sahara, which contains more desert area than the rest of the world combined. What creates these extreme environments? 3 atmospheric and geographic factors work together. The first factor is that these places are positioned directly under the descending air of subtropical high-pressure systems, between 25 degrees and 30 degrees latitude. This descending air compresses, warms, and suppresses cloud formation, essentially creating a planetary scale cover that blocks rainfall. Secondly, many of these locations are on western sides of continents, where cool ocean currents offshore further stabilize the atmosphere and prevent moisture from rising. Third factor is that some, like the Arabian Desert, exist because they're cut off from maritime moisture sources. Africa's unique shape means there's no eastern coast north of 10 degrees north to bring in moisture. These conditions result in precipitation that is scarce, and most regions receive just 5 to 20 centimeters annually. It is unreliable. Let us look at an example from Umahi, Arizona in Sonoran Desert. This region has seen a staggering difference in annual total rainfall. And the rainfall is quite intense, as when rain does come, it arrives in violent downpours that cause flash floods. Temperature-wise, BWH regions are scorching, with summer monthly averages in the mid to high 30s, that is hotter than most equatorial regions. With clear skies and low humidity, temperatures can fall 28 degrees Celsius between afternoon and at dawn. You have to imagine going from needing air conditioning to a winter coat in just few hours. Moving away from the tropics, we encounter BWK, or mid-latitude cold deserts. These exist primarily because they're trapped deep in continental interiors, far from oceanic moisture sources. The largest expanse stretches across central Eurasia, where the massive Himalayas block moist monsoon air from reaching the interior. In North America, the Rockies and Sierra Nevada mountains create rain shadows that produce the Great Basin Desert. Other than these, they are also found in small regions in southern South America, South Africa, and Australia. Unlike their subtropical cousins, BWK regions have a defining feature that is brutally cold winters. The average cold month temperature typically falls below freezing, and some stations experience 6 months with below freezing averages. This creates dramatic seasonal contrasts. While summer days can still reach scorching temperatures, winter brings freezing conditions and occasional snow. Annual temperature ranges can exceed 30 degrees Celsius between seasons. Imagine places that are both furnaces and freezers depending on the month. Precipitation patterns differ too. While still meager and unpredictable, most BWK regions receive their limited rainfall during summer, when continental warming creates instability. Winter is dominated by frigid anticyclonic conditions that suppress moisture. Surrounding the hot deserts are BSH regions or the subtropical steppes. These semi-arid transition zones form a buffer between true deserts and humid climates. What creates them? They typically exist at the margins of the subtropical high-pressure systems where descending air is less persistent. They also form where seasonal shifts in global circulation patterns bring occasional moisture. Take Somalia's capital Mogadishu, a classic BSH location. Its coastal position gives it a small annual temperature range, but what's fascinating is its precipitation pattern. The twice-yearly passage of the intertropical convergence zone creates two distinct wet seasons separated by dry periods. While still experiencing water deficits throughout the year, these regions receive enough precipitation to support more substantial vegetation, typically drought-resistant grasses and scattered trees, that have evolved remarkable adaptations to thrive with limited moisture. Our final category, BSK or mid-latitude steppes, includes some of the world's most important grassland ecosystems. The North American Great Plains, the vast Eurasian steppe stretching from Ukraine to Mongolia, and Argentina's pampas, all fall into this category. These regions form where continental interiors receive just enough moisture to avoid becoming true deserts. They typically exist in rain shadows of mountain ranges, or in transitional zones between humid and arid regions. What makes BSK regions fascinating is their climate's impact on human history. These vast grasslands were cradles of nomadic cultures, and eventually became some of our most important agricultural regions. Even North America's breadbasket exists in a BSK climate. Temperature-wise, they experience cold winters similar to BWK regions. Precipitation, while still limited, is more reliable than in true deserts, and often concentrated in the growing season, making agriculture possible. The natural vegetation here is primarily drought-resistant grasses with deep root systems that has evolved to survive both seasonal drought and grazing pressure. These ecosystems store massive amounts of carbon in their soils, making them crucial in our changing climate. So, why should we care about these Group B climate regions? There are three compelling reasons. First, these regions are expanding. Climate change is pushing dry climate boundaries outward through desertification, threatening food security for millions. Understanding the natural controls of these climates helps us predict and potentially mitigate these changes. Second, they're biodiversity hotspots with species that have evolved extraordinary adaptations, from plants that can remain dormant for decades to animals with remarkable water conservation abilities. These adaptations could inspire solutions to our own resource challenges. Third, they may hold keys to our future. Desert plants have developed water-saving mechanisms that could revolutionize agriculture. Desert-dwelling cultures have centuries of knowledge about surviving with minimal resources. And these vast, sun-drenched landscapes represent some of our best opportunities for solar energy production. As water scarcity becomes a global concern, the lessons from Earth's Group B regions become increasingly valuable. From the scorching Sahara to the frigid Gobi, Earth's Group B climates tell a story of atmospheric physics, geographic positioning, and remarkable adaptation. They remind us that understanding climate systems isn't just academic, it's essential for our future on this planet. If you found this journey through Köppen's dry climates fascinating, hit that subscribe button for more explorations of Earth's diverse environments. Drop a comment telling me which of these 4 climate subtypes you like the most. And if you're curious about other climate classes in Köppen's system, click the bell icon so you don't miss an update. Stay curious, and we will see you in the next environmental adventure.